Alright class, tonight is probably the easiest thing. As far as naming goes, tonight we're going to look at molecular compounds, which are also known as covalent compounds. Right, and if you remember from kind of the very beginning of the unit, these are compounds that are made up of more than one non-metal. Right? So they're called molecular compounds or covalent compounds. They share electrons, and we'll learn quite a bit more about them next semester. But we just want to know how to name them. So the molecular compounds, I'm just going to throw out some examples. PF5, we're going to go NO2, we're going to go NO3, and we'll do P5O10. And that's a good place to start. Alright, so because these are molecular compounds or covalent compounds, we're not worried about charges. Alright? All nonmetals are all negative, so they're never going to add to zero anyways. And so the main thing we're concerned about is how many of each thing do we have. I'm going to add one more, so I'm going to talk about another rule. Alright, so what you need to know with nonmetals is prefixes tell you subscripts. So I'm going to write prefixes down. So we got mono, we got di, we have tri. For 4 it's tetra, which if you played Tetris, all the shapes are 4 boxes. Then we have penta, and we have hexa. And for 7 we have hepta, octa, nona, and lastly we have deca. Alright, so mono stands for 1, di is 2, tri is 3, tetra is 4, penta 5, hexa 6, hepta 7, octa 8, nona, which is N-O-N-A, and then lastly deca is 10. So, because these are binary compounds, just like with ionic compounds, they're going to end in "ide" no matter what we have, because there's 2 elements. So this first one is simply going to be phosphorus. And then before we write fluoride, I'm going to leave a little bit of space, we're going to tell how many fluorides we have. So if we look at our formula, we have 5 fluorides. So I'm going to use the prefix for 5 in front of fluoride. So I'm really going to write phosphorus pentafluoride. Right, and that is it. Next one, we have nitrogen. In this case I have oxygen, which is going to turn into oxide, but I have 2 of them, so it's going to be simply dioxide. Next, and notice this, with our ionic compounds, pretty much only one ratio could work to add up to 0, because again we're not adding up to 0, nitrogen can come in lots of different ways. This is going to be nitrogen trioxide. Alright, our next one, phosphorus, and notice we don't have 1 anymore, we have 5, so it's going to be called pentaphosphorus. And then decaoxide. And typically if we have 2 vowels in a row, we're actually just going to drop the A and just make it decoxide. But if you ever write decaoxide, I'll give you full credit, but typically if we have 2 vowels in a row, an A and an O, we just drop the A and give us the O. So in these 4 examples, what do you notice about the first element? How many phosphoruses do we have? We have 1. How many nitrogens? 1 nitrogen. So in these 3, although we have 1, we don't use mono. Okay? So in this last example, we're going to write carbon, and before we put oxide, we do use mono on the second element. Okay? So mono does mean 1, but we only use it if it's the second element. So in this case we have carbon monoxide. Okay? So again, mono is used only for the second element. We don't use it for the first one. All of our names end in "ide" because we're binary compounds, just like with ionics. Alright? So the next thing is probably the easiest of all, and it is simply going from the name to the formula. So we might have something like this: dinitrogen Again, there's lots of ways nitrogen and oxygen can combine. Dinitrogen Pentoxide, and again, we're just going to call that pentoxide. That should just be an O, pentoxide. We might have, what's another kind of crazy one? I think diphosphorus. Heptafluoride. Kind of easy one would be carbon dioxide, right, which is what we exhale all the time. And let's do tetra. I don't even know. I'm gonna make this one up. This probably doesn't really exist, but tetrasilicon, octa bromide. Alright, so for this first one, dinitrogen pentoxide, we know we have nitrogens, and with our prefix di, we actually have 2 nitrogens, and we know we have oxygen, and because it begins with a penta, we know we have 5 of them. Our next example, diphosphorus heptafluoride, so we know we have phosphorus, and we have 2 of them. We know we have fluorine, right, and we have 7 of those. Next, carbon dioxide, we have carbon, and we have oxygen, and we have 2 oxygens. And lastly, tetrasilicon, so silicon, we have 4 of those, and then octa bromide. So we're going to have 8 bromines. Alright, the other thing that doesn't matter is we're not going to, with our ionic compounds, we always chose the least common, or the lowest whole number ratio. Notice up here for pentaphosphorus dicoxide, we have a 5 to 10 ratio. That could be a 1 to 2. If we're talking about ionic compounds, we would make it 1 to 2. But molecular compounds, the numbers that you see are the actual numbers that exist in that molecule, so we're never going to simplify it. Similarly with the tetrasilicon octabromide, it's a 1 to 2 ratio, but it's exactly 4 silicons with exactly 8 bromines. Okay? And that is it for molecular compounds.